Hello all, my name is Shalini Singh and this video is the fourth part of the Open Channel Flow series. The link to the first, second and the third part is given below in the description box. The contents of this video are specific energy curve, critical flow and critical depth. In the previous video we have learned that the specific energy equation is given as E equal to Y plus Q square by 2GY square. Here E is the specific energy, Y is the depth of flow, small q is the discharge per unit width and G is acceleration due to gravity. Now the concept of specific energy is very useful in the analysis of flow problems. And it can be noted that the total energy in a real fluid flow always decreases in the downstream direction. But the specific energy is constant for a uniform flow. Here we can see the total energy line will be always decreasing in the downstream direction, but for uniform flow, this distance from here to here, that is the specific energy, which is the summation of potential head plus kinetic head, that will remain always constant. So, if Y decreases, then kinetic energy will increase, and if Y increases, then kinetic energy will decrease. So, we see here, as Y tends to 0, Q square by 2GY square will tend to infinity, because Y will be very small and E will thus tend to infinity. But for larger depths, the kinetic energy attains a low value and E will tend to Y. Specific energy curve. The variation of E with Y is called specific energy curve. In this specific energy curve, the x-axis denotes specific energy and the y-axis denotes the depth of flow, this one. If both the axes have identical scales, the potential energy line OP will make an angle of 45 degrees with both the axes. So, if y is the distance from origin to this point, then this distance will be also y, because this is 45 degree. And we know specific energy is the summation of potential head plus kinetic head. So this distance will be v square by 2g. The specific energy curve has been drawn for discharges Q1, Q2 and Q3, such that Q2 is greater than Q1 and Q3 is greater than Q2. It can also be seen from the curve that as y varies from a lower value to a higher value, here y is increasing, the specific energy first decreases, attaining a minimum value at a certain depth, then increases with the depth till it is asymptotic to the potential energy line OP, which means this curve and this line will never meet. It can also be seen that the curve is asymptotic to E-axis also. The depth of flow at which the specific energy attains a minimum value, meaning for this discharge curve, this point, it is called the critical depth and is denoted by YC. Points C1, C2, C3 represents points for minimum specific energy for the three curves respectively, and the line joining C1, C2, C3 with the origin of axis O makes an angle alpha with the horizontal. And it has been observed that for rectangular channel, tan alpha equals to 2 by 3 and alpha equals to 33.7 degree. If a vertical line MN representing a given specific energy where E is greater than E minimum, this E1 is greater than E minimum is drawn, it intersects the specific energy curve at 2 points M and N. These points M and N represent two possible depths of flow which are known as alternate depths. At point M, Y is less than YC and the flow represents supercritical flow. And at point N, Y is greater than YC and the flow represents subcritical flow. The flow at the critical depth is called the critical flow and the velocity of flow is known as critical velocity. When the depth is less than the critical depth, the velocity of flow is greater than the critical velocity and hence the flow is said to be supercritical or rapid flow. If the depth of flow is greater than the critical depth, the velocity is less than the critical velocity and then the flow is called subcritical or tranquil flow. Before we move further, we should know about Froude number. Froude number is the square root of the ratio of inertia force to gravity force. Now, inertia force we all know F equals to mass into acceleration, and mass can be written as density into volume, which can be written as rho L cube, where L is the dimension of length, and acceleration is equal to velocity by time. Time can be written as distance by velocity. So A is equal to V by L by V, which is equal to V square by L. Putting all these values into the equation of inertia force, we get Fi equals to rho L cube into V square by L, which is equal to rho L square into V square. Gravity force Fg is equal to m into g. Again, m can be written as rho L cube. So, Fg is equal to rho L cube into g. So, Froude number equals to square root of rho L square V square by rho L cube into g. Cancelling all the common elements, we get Froude number equals to square root of V square by Lg, which is equal to V by square root Lg. If we write d instead of L, which is the depth of flow, Froude number becomes V by square root g into d. Critical flow. The critical flow has been defined as that flow at which the specific energy is minimum for a given discharge. Now E is equal to Y plus V square by 2G. Putting the value of V as Q by A, we get E equals to Y plus Q square by 2G into A square. For minimum specific energy, differentiating the expression for E with respect to Y and equating it to 0, we get dE by dy equal to 1 minus Q square by 2G into 2 by A cube into dA by dy. If T is the top width of the channel, then dA equals to T into dy. And dA by dy equals to T. Therefore, dE by dy becomes 1 minus Q square T by GA cube. For minimum specific energy, dE by dy will be equal to 0, or q square into T by G A cube equals to 1, or q square by G is equal to A cube by T. So this equation is the equation for critical flow. We can also write q square by G square equals to A by T, or V square by G equals to A by T. Putting A by T equals to D, that is the hydraulic depth, V square by G equals to D, or V square by 2G equals T by 2. Finally, we get V by square root G, D equals to 1, and that is the Froude number. So the above equation states that in critical flow, the velocity head is equal to half the hydraulic depth. And for critical flow, the Froude number is always 1. Critical depth for rectangular channel. For a rectangular channel, we know area is equal to B into Y. This one. And the top width is equal to B. Recalling the critical flow equation, we have Q square Tc by G A cube equals to Vc square by G Yc. And this should be equal to 1. This is a Froude number. So this is equal to 1. So we can see here V square by 2G will be equal to Yc by 2, and specific energy is Y plus V square by 2G. So putting all the values for critical flow, we get E equals to Yc plus Vc square by 2G, which is equal to Yc plus Yc by 2, which becomes 3 by 2 into Yc. Also, small q is discharge per unit width. So small q square by G will be equal to Yc cube, or Yc equals to q square by G to the power 1 by 3. Now since A by T equals to Y, the Froude number for a rectangular channel is given as F equals to V by square root G into Y, where Y is the depth of flow. Trapezoidal channel. Here A is given as Y into B plus My, and T, the top width, is equal to B plus 2My. At critical flow, Vc square by G is equal to AC by Tc. AC by Tc is the area at critical flow, and Tc is the top width at critical flow. So putting the value of AC and TC, we get Yc into B plus Ym by B plus 2Ym. So if we see this term, B plus Ym by B plus 2Ym, we know this will be less than 1. So this whole term will be less than Yc, or Vc square by 2G will be less than Yc by 2, and E is equal to Yc plus Vc square by 2G, which should be less than Yc plus Yc by 2, which will be less than 3 by 2 into Yc, or Yc will be less than 2 by 3 E, it is the specific energy. Triangular channel. For a triangular channel having a side slope of m horizontal to 1 vertical, area is m into y square, and t, the top width, is equal to 2 into m into y. Now for critical flow, q square by G is equal to AC cube by TC. Putting the values of A and T, we get q square by G equals to m3 into Yc raised to the power 6 by 2m into Yc, which will be equal to m square yc raised to the power 5 by 2. So we get yc equal to 2q square by gm square raised to the power 1 by 5. E is equal to yc plus vc square by 2g or yc plus q square by 2g a square. Putting the value of q and a, we get E equals to yc plus m square into yc raised to the power 5 by 4m square yc raised to the power 5, which finally equals to 1.25 into yc. And a by t, that is area by top width for a channel, equals to y by 2 triangular channel. So the Froude number will be finally equal to v into square root 2 by square root g into y. Critical slope. The critical slope is the value of the slope which can be obtained from Manning's or Cherry equation, at which the uniform flow at specific rate q occurs under critical flow condition. Critical depth in a channel can be obtained from the equation q squared g equals to aq by t. And the Manning's equation may be written as q equals to 1 by n into AC RC raised to the power 2 by 3 SC raised to the power half. Here RC is the hydraulic radius at the critical depth YC, AC is the area of flow at Y equals to YC, and SC is the critical slope. Jay's equation will be given by Q equals to C AC square root RC into SC. In this video, we learnt about critical depth and flow. In the next video, we'll learn more about specific energy and its application. Thank you and God bless you all.